Hi, this is Cam Starmer coming to you live from CNN8. Today our main focus is going to be on the nitrogen cycle. Right now I'm live with our guest scientists, Josh Stafford and Owen Zelski. Today they are going to be giving you an explanation of the nitrogen cycle. Now to you, Josh and Owen.
Thanks, Cam. The nitrogen cycle is a long process with many steps involved. But first, we need to talk about the importance of it. Nitrogen is important because plants and animals use it to make DNA, RNA, and amino acids, which are the building blocks of proteins.
The cycle starts with nitrogen gas in the atmosphere, where it takes up 78% of the atmosphere. Unfortunately, nitrogen gas has a triple bond, is unusable by most living things. One of the living things that can use this gas is nitrogen-fixing bacteria. These bacteria can mostly be found in legume root nodules. Both bacteria and fertilizer industries convert nitrogen gas into ammonia by splitting the gas and adding hydrogen to create ammonia. This can be processed down further to make ammonium nitrate, which is then usable by plants. This process is called nitrogen fixation.
Now that nitrogen is usable for plants, some plants will take more ammonia and use the nitrogen for DNA and RNA and amino acids that eventually are made into proteins. This part of the process is called assimilation.
Since not all plants can take in nitrogen-fixed ammonia, nitrifying bacteria add oxygen to make NH3, ammonia, and make it into NO2, nitrate. Then they add more oxygen, making it NO3, nitrate. Nitrate is a chemical and fertilizer that we can add directly to plants to make them create proteins quickly, which result in faster growth. Once plants or animals die, decomposers slowly break down the bodies of organisms and release ammonia into the soil. This process is called mineralization and works to release more nitrogen into the soil. This process closely relates to another process called ammonification. Ammonification is the second half of releasing the nitrogen back into the soil from dead animals or plants. The final part of the cycle is getting the nitrogen from the soil back into the atmosphere. This step is called denitrification. The process can start when soil gets so wet that the water fills the spaces between the soil particles. This leaves little to no oxygen for the microorganisms to get their oxygen. This means that the oxygen that they get from nitrites or nitrates, when they take the O2, nitrogen, and nitrous oxide gases form, which are then released back into the atmosphere, restarting the cycle with nitrogen fixation.
Thanks, Owen and Josh, for that great explanation on the cycle. Now we're going back to Owen on a study how vehicle exhaust emissions affect urban wildlife and plant species.
Thanks, Cam. Due to the vehicle emissions, a ton of nitrogen dioxide, nitric oxide, ozone, and fine particles are released in the atmosphere. This results in high amounts of pollutants into urban areas. GNB Bell, the scientist behind the study, states that pollutant characteristics of major urban roadside locations can produce both reductions and stimulants to plant performance. These effects come from the excessive release of carbon dioxide emissions from vehicle emissions into the atmosphere that plants can take in to start nitrofixation in the nitrogen cycle, which surprisingly results in plants doing better when exposed to more carbon emissions. Now we're going to get an ad from our sponsor about how we can reduce these carbon emissions using better vehicles.
In a world where air quality is declining and our planet's at stake, it's time for a change. Introducing electric vehicles, driving towards a cleaner future. Nitrogen is essential for life, but excess nitrogen from fossil fuel combustion can disrupt this delicate balance. It leads to air and water pollution, harming ecosystems. By choosing electric vehicles, we can lower nitrogen oxides in the atmosphere, reducing acid rain and promoting healthier water systems. Join the movement towards a sustainable transportation. Drive an energy drive car. Now, contact us at 517-123-4567.
Thanks, Cam. There are many different things humans are doing that affect the nitrogen cycle. Some examples include deforestation, fertilizer runoff, factory emissions, and wastewater management. First of all, deforestation, the conversion of inorganic forms of nitrogen found in non-living systems to organic forms of nitrogen found in living systems can't happen. According to umass.edu, deforestation messes up the nitrogen cycle by reducing nitrogen-fixing plants, causing soil erosion, disrupting helpful microbes, and increasing nitrogen into the water. This leads to poor soil and environmental issues. With this, we know that deforestation hurts nitrogen levels in different ways in different places. Another human impact of the nitrogen cycle is fertilizer runoff. This is where excess fertilizer containing nitrogen is washed away from agricultural fields to different kinds of bodies of water due to irrigation or rain. Runoff leads to nutrient pollution in nearby bodies of water. With this, algal blooms dies and then decomposes, creating dead zones where no aquatic life can survive. Overall, it disrupts the natural balance of the cycle, leading to severe ecological consequences. Are your plants dead, sick, or maybe even dying? Try our new Fertigen. We pride our fertilizer on containing 70% nitrogen to improve your plant growth. We are the only fertilizer for your garden. However, be wary that an excess use of this can disrupt the natural nitrogen cycle. Please use responsibly to ensure a lush garden and healthy environment. Refunds not available. Factory emissions also have a massive human impact on the cycle. When fossil fuels are burned into the atmosphere, they can lead to acid rains and excess amounts of nitrogen in ecosystems. They are then stored in the atmosphere, where they become a greenhouse gas. Overall, burning fossil fuels disrupt the nitrogen cycle, leading to the environmental imbalances that harm the ecosystem. Lastly, wastewater management. From before, we know that places with low oxygen levels are the best place for denitrification to occur. With poor waste management, excess nitrogen can be released into bodies of water like lakes and rivers. So with this poor waste management, excess nitrogen gas can be created and can completely mess up the cycle.
Thank you for tuning in live at CNN today. Thank you to my special guests, and we'll see you next time.